Welcome to video lesson 5.2, which is direct variation. Go ahead and put today's date in the top right hand corner. And our target for this lesson is that I can graph direct variation and find constant variation. Now, our very first vocabulary word is direct variation, and it just means that y varies directly with x. And that kind of comes back to our slope in that as the changes in y, there's also changes with x. So direct variation is a line involving our slope. All right, and it looks like this right here for the equation. Y equals kx. And for today, k is going to be our slope and the constant variation. I know in our previous video we said slope was m, and for our finding our slope and for our slope-intercept form, slope will be m. But just for today, where we're looking at variation, it's the variable k. And just remember that it's just a variable. Variables can change, okay? So k is our constant variation, and it's also our slope. If you notice, k is right beside of your x, so the coefficient with x is going to be your slope. Whatever's in front of your x is going to be your slope. And what we will see later on is that it will change to an m. So k for today is our slope. And it says in direct variation, k, there you go, k always passes through the origin. So that means the first point we'll plot will be 0, 0. Okay, and then we're going to look at what family of graphs. And family of graphs include graphs and equations that have at least one characteristic. Now, a family of graphs would, one characteristic in common. An example of family of graphs would be like our linear equations, because we know all of our linear equations from our previous chapter. If we look at the very first four letters of linear, it says line. So all linear equations are lines. So therefore, they're a family of graphs. And then our very last vocabulary word is our parent graph. And parent graph is the simplest graph of the family. So it's like with our linear equations, our simplest one would just be y equals x. Because we have 1y, 1x, nothing else there. So our parent graph for our linear equations would just be like y equals x. So now, before we begin our examples, I just want to stress again that k is our slope and our our constant variation. So if we're asked to find constant variation, we're truly looking for slope. So let's look at our first example here. It says name the constant variation for each equation. So remember we said constant variation is our slope, and it says then find the slope of the line that passes through the 2 points. So if we're looking for constant variation, we're also looking for slope. It's just wanting you to realize that both should be the same thing. Your constant variation and your slope should be the same. So remember, for today, slope gets the variable k. So I'm going to put k equals. We know from our previous lessons that it's rise over run when we're looking at a graph. And we want to find our farthest point on the left. So it's right here at 0, 0. Then count how many we go up for our rise. We rise 1, 2, 3. And we run 1. And then we say 3 over 1 can reduce to just 3. So our constant variation and our slope for our first example is 3. And as always, just double check, make sure if it's a positive slope down here that the line's going up to the right, and it is, so we're good. So let's move on to our example B for our first example. Okay, so once again, we're going to be finding slope, and that's our variable k today. And once again, it's on a graph, so I'm going to be looking at rise over run. And we find the slope the same way we read. So I'm going to find the farthest left point, count my way to the one on the right. So I'm going to have to go down 1, 2. And since I went down, it's a negative 2. Over, I have to run over 1. So negative 2 over 1. Negative 2 divided by 1 reduces to negative 2. And it's a negative number here, so let's make sure our line goes down to the right. It does, so our slope's negative, and our slope's negative. So our constant variation and our slope for B is negative 2. Now let's look at our second example. Oh, I'm sorry, we have to get a little bit of notice before we look at our second example. It says to graph direct variation. So this is where we're going to start actually graphing our slope. So it says find slope, and just a reminder, it's the number in front of x, and then write as a fraction. Now, the reason why we want to write it as a fraction so we know our rise over run. So once again, it's variable k today. It's rise over run. And whenever we write it as a fraction, it's like if we get a slope of 2, then I'm going to say it's 2 over 1, because 1 can go into 2 times. And then that way I have a fraction. I know to rise 2 and run 1. And for any integer, 1 will go on the bottom. Second step, plot the point 0, 0, which is the origin first. So just a reminder that all of our graphs today start at the origin, 0, 0. Our third step is to actually use our slope. So from the point, from 0, 0, we're going to use our slope. Once again, a reminder, that's rise over run. And here's how we're going to use our slope. If it's positive, we're going to rise and go up and to the right. But if for some reason your graph's not big enough to go up and right, you can also go down and left. Same way with your negative slope. We want to go down and to the right for negative slope. But if our graph's not big enough, we can go up and left. But we always want to try these first. We always want to see if we can go up and right or down and right first. Okay. Our next one is a slope of 0, is a horizontal line. An easy way to remember that is to just say, what does 0 start with? A Z. Horizontal has the letter Z in it. And it's also for when we get the equation y equals 2. If you notice, there's no x there, and there should be. So when there's no x, it's a horizontal line. Lastly, it's when it's an undefined slope. And that's when it's x equals a number. Because there's no y, it gives you a vertical line. And lastly, our fourth and final step says make a line through the points. Just a reminder, we want a long line with arrows on each end. Remember, lines show infinity. They go in all directions. So you want to use your arrows to show that they continue onward. So now it's time to go on to our second example. So example 2 says to graph y equals 4. So if we pull back up our steps, step 1 says find the slope. So it says slope is the number in front of x. Our number in front of x here is 4. Then it says to write it as a fraction. So if it's an integer 4, I say 4 over 1. Then it says we need to begin at the origin. So I'm going to put 0, 0, 0. Now we have all of our information, so we'll start graphing. So to make yourself a coordinate plane, you can go 5 in every direction if you want to. That way you have enough room. Don't forget to label your axis. X is the one that runs left and right. y runs up and down. So we plot our point first. Plot point first, so 0, 0. So 0, 0. And then my slope is 4 over 1, so it's positive. So I'm going to rise 4. Rise 4. And then I'm going to run 1. And we run right. So up 1, 2, 3, 4. Run right once. I have 2 points. And also, we said if we can't go up and right, we could go from the origin down 1, 2, 3, 4, and left. So if you notice, that's still in our line. That's still part of it. So now I'm going to grab my line here. Oh, just lost it. There you go. Grab my line here. Take my line through my points. Now, you all might want to use straight edges. That way your line's nice and neat and straight. And when we do our practice, we'll use straight edges. So that's graphing slope. We always begin at the origin, and then we rise if it's positive, so we go up and to the right. Now, on to our third example. Oh, there we go. So example 3 has y equals a negative 1/3 x. So once again, first step, find our slope, which is k, and it's the number beside our x, so negative 1/3. Okay, and it's already a fraction, so I don't have to worry about writing it as a fraction because it already is a fraction. And then we said all of our graphs are going to start at the origin, so 0, 0. And we're going to plot our point first. So we plot 0, 0 on our graph. And if you just want to make another coordinate plane the same way our last one, just 5 by 5, label your x-axis and your y. Okay. So then, plot the point first, 0, 0. And then our slope this time is negative. So that means I need to go down because it's negative, and we always run right if we can. So I'm going to go down 1, and then I'm going to run right 3. 1, 2, 3. And then same way, if I can't go down and right, I can go up and left. If you notice, that's also in my same line there. So grab my line, put a line through it. There we go. I'm going to show both examples here for just a second, example 2 and example 3. You can always go back through until you've graphed them correctly. If this slope is positive and your line's going up to the right, and then your slope's negative and you're going down to the right. But also, they call slope today the constant variation because that's what your graph's going to be constantly rising and running by. It's like I put 3 points here, but really I could make however many I wanted. I could go up 4 and right 1 again. And same way over here. I could go down 1 and right 3 again. So constant variation means that's your constant change in your line. Your line's going to be constantly rising and running that same variation for all of infinity because you got arrows on both ends and you can go in all directions with that same variation. All right, now let's look at our last example. Example 4. It wants us to, given this prop, write a direct variation equation that expresses x and y, that relates x and y. So it says, suppose y varies directly as x, so that's our definition for direct variation. It says if y equals 28 and x equals 7. Let's write that down. We have y equals 28, x equals 7. And now we need to write an equation. So the very first thing we're going to do is grab our direct variation equation, y equals kx, and plug in what we know. We know y is 28 equals k times, we know x is 7. So now we need to solve for k so I can get what k is. So if k and 7 are side by side, that means they're being multiplied. So I need to do the opposite and divide both sides by 7 so I can solve for k. So 7's cancel. And 28 divided by 7 is 4. So 4 equals k. Now that's not an equation. That's just what k is. The same way we can say y is 28 and x is 7. We know k is 4. However, to write the equation, we have to write, once again, our y equals, except this time our k is going to get replaced by our 4. 4, and then we're going to bring over our x. And this is a direct variation equation because it looks like this guy, all except for I now know the value of k. K is 4, so we substituted him in. Now it says to use the direct variation equation to find x when y is 52. So for part B, we're going to go back to our y equals 4x. And this time it says y is 52. So I can replace y with 52 equals 4x. And now we're trying to find x. So I'm going to divide both sides by 4 to solve for x. 4's cancel. 52 divided by 4 is 13 equals x. So when your y value is 52, your x value is going to be 13. So that's just using your direct variation to solve for missing pieces, like missing constant variation, or to find a value for x when you're given y. And that concludes our direct variation. Thank you very much.